So, how much skin would you get if you would actually skin a human being? The answer is about 2 square meters, which will mean almost nothing to everyone watching this video. So to help you visualize it, here I have a square meter. So the area of the front and the back is 2 square meters. So if I were to skin the front of me, then the skin of the front of me would actually take up the area of the front of this. Now that's maybe nominally interesting, but the thing that's really impressive about this is just how much atmospheric pressure there is pushing down on 1 square meter. So atmospheric pressure is equal to about 10 meters of water. So that's like 10 times this distance here. So if I were to put 10 meters on top of my 1 square meter, a cubic meter of water weighs about a ton. So 10 cubic meters pushing down on 1 square meter would give you a pressure of 10 tons pushing down on this square meter. Or looked at another way, if I were to take myself and put myself on a planet with no atmosphere, so there's then no atmospheric pressure pushing down on my skin, on my 2 square meters of skin, I would need to park 20 tons on my skin to give me the same pressure that is on my skin at the moment. Now, most people, when they're told that there's about 20 tons pushing down on their skin, will say, well, why aren't I crushed? And the answer is the liquid stuff is fairly simple, because liquids are fairly incompressible. You know, we use them in hydraulics, that sort of thing. Or looked at another way, the density of water at the surface when there's only 1 atmosphere of pressure pushing on it is almost exactly the same as the density 10 meters down. Water is very incompressible stuff, so you don't really feel the pressure there. Where you do feel the pressure is in the atmosphere. So the most obvious one is when you change altitudes quickly in a plane, it makes your ears go pop. But if you really want to feel this 20 tons on your skin, what you need is a different pressure on the inside of your lungs than on the outside. And I'm going to give you a little demonstration to show how that works. So this guy here is a vacuum pump, and it's got a pressure meter on it. And it's giving a readout in terms of essentially atmospheres. So when this is 1,000, that's 1 atmosphere. So if I actually turn the pump on, you'll see that the pressure on the inside, I'm sealing it here with my finger, starts to go down. And already I'm down to about half an atmosphere. And the highest point on Earth, Mount Everest, has about 1/3 to 1/4 of an atmosphere of pressure, which is to the point where if you're breathing an atmosphere that thin, and there's just not enough oxygen for you to survive, it takes more energy to breathe the air than you actually get out of the air. And so this is now roughly what the atmosphere on Everest is like. So what I'm going to do first is I'm going to just see how much of a vacuum I can suck. Now, bear in mind, this isn't going to be the pressure difference between the atmosphere and my lungs, because I'm going to make the seal with my tongue here, okay? So I'm just going to see how much I can suck. Okay, that's about as far as I can go. It's about 0.7 of an atmosphere. But that's not the difference between the pressure on my skin and the pressure in my lungs. So what I'm going to do now is I'm just going to suck really hard on this. So this is 1 atmosphere at the moment, and see what sort of pressure difference I can pull between the sucking air in against atmospheric pressure pushing on my skin, okay? Okay, so that's basically as hard as I can do, and it's only about 1/10 of an atmosphere difference between what I can suck in and what's pushing on my skin. And I can do the other way around as well. So I'm now going to blow as hard as I can and see how much pressure I can exert with my lungs. So again, it's It's about a tenth of an atmosphere difference. I've got stars now. A tenth of an atmosphere difference is as hard as I can breathe out. Even that's actually quite impressive if you think about it. Remember what I was telling you earlier, that atmospheric pressure is equal to about 20 tons pushing on your skin. So merely getting a tenth of an atmosphere is the equivalent pressure of about 2 tons pushing on your skin. So when I'm breathing out against that, that's sort of the equivalent of having 2 extra tons difference in pressure per square meter between what I'm breathing out and what's pushing on my skin, which is why if you were to have an oxygen supply which is at a different pressure than the atmospheric pressure, you would just, the action of moving your lungs in and out, actually pushing against that 20 tons that's pushing on your skin versus the, 18 tons per square meter that's actually on your air supply, it would exhaust you and kill you very quickly. So, just some fun things you can do with a vacuum pump and a pressure meter.